So car A is traveling west at 50 miles per hour, and car B is traveling north at 60 miles per hour. Both are headed for the intersection of the two roads. So what should we do right now? Draw a picture. Okay, so I have car A. What direction is it going? Okay. And is that a constant or is that changing? It's changing. Okay, and car B is somewhere going north and they are heading for the intersection. So these two cars are going to meet up at some point. Okay, I'm going to call this like side A and side B just for the distance car A has traveled and the distance car B has traveled. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? So what would be their distance from each other? Where does that go in my picture? Yeah, that's like side C. That's your hypotenuse. Okay, so if we write down the stuff we know, car A is 0.3 miles from the intersection. So that means the distance A is 0.3. Car B is 0.4, so that distance is 0.4. We want the rate they are approaching each other, so that would be like dc dt. A rate is a derivative. We're talking about the distance apart, so that's what I'm looking for. Do I know dA dt?
Would that be the speed each one?
So dA dt would be 50. dB dt would be 60. Okay. What kind of formula would I set up here? Okay, so to get all of the dc dt, dA dt, dB dt, what do we have to do? Derivative. So what would the derivative of this be? 2a dA dt plus equals there are no constants in this one, so we couldn't plug in anything before the derivative. Alright, so now if we start plugging in, we have 2, A is 0.3, dA dt is 50, plus 2, B is 0.4, dB dt is 60, equals 2. I don't know C, and I'm looking for dc dt. How could I find my C? We know we're looking for C at this instant when A and B are 0.3 and 0.4, so if we plug those in, 0.3 squared plus 0.4 squared equals C squared. So we get C to equal 0.5. So if we start multiplying, We get dc dt to equal 78. What would my units be? Miles per hour. C was a distance, T is our time. Does that seem reasonable? If both cars are driving, would the distance between them be, would they be approaching each other faster than either of those individual speeds? Yes, because they're going towards each other. Okay. Questions on that? Why don't you take a second and read the next one and see if you can figure out how to start it. I don't want you to solve too much because this one's a little challenging to set up. I just want you to see what you can get. So a man, 6 feet tall, walks with a speed of 8 feet per second away from a street lamp that is atop an 18-foot pole. So I saw a lot of triangles walking around. You've got, your street light here. And we have, he is walking away from it. So you've got your person over here walking away. Okay, and we know he is 6 feet tall and the pole is 18 feet tall. Okay. I want to know how fast the tip of his shadow is moving along the ground. Where is his shadow going to go? On the ground. And if the light's behind you, your shadow would be in front of you. So we're talking about his shadow is out here. So the tip of the shadow would be down there. Okay. And we want to know how fast that is moving. So we really have a triangle here. How many triangles are in this picture? 2 of them. We've got the big one where the height is 18, and then you've got the smaller one where the height is 6. Now we need to figure out what we're going to label the bottoms of these triangles. Okay, we know he is walking 8 feet per second away. So that means this is telling me a speed for how far away he is from the triangle. So it's talking about this distance right here. So that's going to have to be one of our variables. Let's say if I call that x. Then the tip of the shadow, I want to know how fast that's moving along the ground. So that is this whole side here. So I need a variable for it. So maybe I call that y. Okay, so I kind of picked where to put my variables based on the speeds that were asked for in the problem. Because if I'm going to ask for how fast he's walking away, then I need a variable for the distance he has walked. If I want to know how fast this point is moving, then I need a variable for the distance that point has moved. Does that make sense? Okay, so that's why I can't just say this piece is x and this is y over here. Y had to be the whole thing because I want the distance, the speed this point on the end has moved. So it has to be the total distance. So in my triangles, this total side is y. What would this one be? Yeah, it's this piece right here. The whole thing is y, so if you take off x of that, this is y minus x. So that one really is a little bit trickier to set up and as far as how to pick your variables. Okay, have I lost anybody to this point? have our picture, we have our information. Let's start writing down what our variables are. His speed that he's walking away. So x is the distance he has walked. So that means the dx dt will be 8. Okay, I want to know how fast the tip of the shadow is moving. So y is the distance for the shadow. So dy dt is the thing I'm looking for. When he is 100 feet from the light pole. So what variable is that? X. Okay. What kind of formula could we set up for this? What kind of equation could we do? Can't do Pythagorean theorem because I don't have 3 sides in a triangle. What's true about these 2 triangles? Similar triangles, because one is just an enlarged version of the other. So do you remember with similar triangles we can do proportions? So several different ways you could set up, but I could say y over 18 equals, then you pick the corresponding sides in the other triangle. So y was the base, so the base over here is y minus x. 18 was the height, so the height over there is 6. Okay, what would we do now? I probably don't want to do the derivative of this yet. It's kind of ugly. Cross multiply. So y times 6 would be a 6y equals 18 times the y minus x. So let's see, if I add over my 18x, subtract over my 6y, get to this. What now? We're trying to get dx's, dt's, dy, dt's derivative. We could have done the derivative, up here, but I just figured it would be nicer to not have the fractions to deal with. So we just simplified it a bit, but now let's do our derivative. Derivative of 18x would become 18 dx dt. Derivative of 12y would be 12. So if we plug in, dx dt is 8. We'll divide our 12. So 18 times 8 divided by 12. We get 12. What would my units be? Feet per second. So did I even need the x equals 100 to solve this? No, it's just extra information. Alright, so that's definitely the most challenging one we've done so far. Questions? I like to do one more, I think, and that'll probably be my stopping point for today. What? A waffle cone. Is that better? You want to think you have like your ice cream's dripping out of your waffle cone. Okay, a water tank has the shape of an inverted circular cone. So, inverted circular cone. That's your waffle cone. Inverted means upside down. The base radius is 2 meters. So where would that be? Yeah, the circle up at the top. That has a radius of 2. Now, is that constant throughout the cone? No, because as you go down, the radius is going to narrow. And the height of 4. So the total cone has a height of 4. Water is being pumped into the tank at a rate of 2 cubic meters per minute. Find the rate at which the water level is rising when the water is 3 meters deep. So what's happening is we are filling this up. We're dumping water in here. The rate of that, if I'm talking about cubic meters, what is that? Volume. So cubic meters per minute would be dB dt. That's just talking about the amount of water. That's 2. Find the rate at which the water level is rising. So that's talking about d what? I'm talking about how fast it's rising. I'm talking about the height. So I'm looking for dH dt. At the instant when the water is 3 meters deep. So at the instant when the height is 3 exactly. Okay. I'm talking about volume. Does anybody know the formula for volume of a cone? It's 1/3 pi r squared h. Okay, here's the problem. You had one of these on your homework with a cylinder. So the volume was just pi r squared h. And you saw, if you just did this derivative right here, you would end up doing product rule. You're going to have a dH dt, a dr dt, and a dV dt. Do I have all of those pieces up here? No. So really, if I try to do this derivative right now, I'm going to have more variables than I can solve for. Think about that number 5 on your homework. How did you get around that problem? What did you know? It was a cylinder, and it told you that the radius was 5. So the radius didn't change in that, and you were able to plug it in sooner. Is my radius constant in this? No. But is the radius somehow related to the height so that I could maybe change them to the same variable? So what I'm asking, if we took this, we could think of this as a triangle, couldn't we? If you're looking at the whole thing, the height was 4 and the radius is 2. I am looking at one point in this. So in general, this is the height and that's your radius. Think about what we did on the last problem. What's true about those triangles? They're similar. So 2 over 4 would have to equal r over h. I want to get rid of my r because ultimately I'm looking for dH dt. So I want to keep h. So if I solve for r up there, you could just multiply over your h. 2 over 4 is 1/2 h equals r. So what this tells me is the radius is just half the height. Is that true for the whole thing? The radius is half the height? So while I don't just have a number, I can plug in for my radius. I could rewrite it in terms of h and say, instead of using that r there because that'll give me too many variables, let's change that to 1/2 h. Have I lost anyone? So if I simplify that, can I write 1/3 pi as pi over 3? Is that okay? 1/2 squared would be 1/4 h squared times h. So my volume is pi over 12 h cubed. So I just cleaned it up by multiplying together my coefficients and my h's. From here, now what am I ready to do? Derivative. We have a much prettier equation, so let's just do this derivative. Derivative of v would be dv dt. Over here, the 3 comes down, so 3 pi over 12, or just pi over 4. H, subtract 1 from the power, and it gets a dh dt. What was dv dt? At the instant we're concerned with, what was our h? Okay, so if I multiply over my 4, divide by my 9 pi, my dh dt is 8 over 9 pi. H was the height. My height here was measured in meters per. T was time, and my time was measured in minutes. So that tells me at that instant how fast the height is rising. Let me ask you a question. As your cone fills, is the HDT going to go up or down? Will your rate increase or decrease as we're going? Decrease. Does that make sense? If you think about your cone, if you're pouring water in at a constant rate, the bottom is very narrow. So at the bottom, the height's rising really fast. But as you get to the top, it's spreading out, so it's going to take longer for that to go up. All right. Questions? So what I'd like to do is just stop here today and give you guys time to work on a few more problems individually. Add these to the 3 from yesterday. So we are going to add on 9, 11, and 13.